Okay, this is the Zoom lecture for construction surveying on Monday, April 13th. And at about 7:45, it's 6:30 p.m. right now. At 7:45, we'll do a little bit of heavy civil. So I'm going to let somebody else in here. And I'm just going to go over this survey really quick. This actually happened, like I said, my good friend Ron Mullinex did the survey for this. And this guy just went ahead and built his house, over 50% of it on somebody else's property. And the one red flag that a couple of you caught, one of you had an interesting point that if you were owner number 2 and you put up a fence on your own property, that would have been a kind of a red flag. The big one is if owner number 1 had an original survey, right? All they had was a deed, which is just a written description of these boundaries, these distances and bearings. The solution based on what you see is a boundary line adjustment. So the surveyor went in, working for owner number 1, surveyed the portion of the property that the owner number 2 was willing to sell, and then that became part of this 5.611 acre, in addition to the 5.611 acre. I forgot to mention, one of the other red flags is when this guy went for a building permit to build all this stuff. That should have been a red flag to someone, but again, it was not, which was unfortunate. And the two other possible solutions, one, of course, is to demo it. If you're the owner number 2, you can just tell them, hey, demolish it, or actually move it. And then, of course, you can go to court, which you really don't want to do. So the boundary line adjustment is the best possible solution, but it really depends on what this owner number 2 had in mind for his or her property. So that was the first homework that was due. The second homework that we'll talk a little bit about tonight, and we'll go back to it in a couple of weeks because we're not going to do any COGO tonight with new stuff. We're going to talk about doing a topographic survey and field notes for that. But here's my calculations. And if you went out to thousandths, I think it was 0.338, 0.004. So the distance from WP1, which is the instrument setup point, it's N1E1. And then the first point that we wanted was W3. Because it's a southerly dimension, this point is south, only about 10 feet of the north 0 line. That would be a negative when you burp it into the equations. So it's negative 9.61 minus the 63.73. So it's N2 minus N1 squared, and so on. So these are the answers. Most of them got them right. I hope you use the coordinate geometry. Let me bring that over. And again, this is yours to use on Vanco Hall. And again, this was made by a good friend of ours, Professor Vogt, back in the day. And there's W working point 3. N1E1 is at working point 1. So everything in yellow is the data for the angle and distance to working point 3. Everything in green is working point 4, which is right here. So that's working point 4 right there with different northings and eastings and so on. And again, you're using these coordinate axes, which are running north-south, whoops, and east-west. So hopefully with your we're going to try to give you an exam in the next week or two. So with your calculations, or hell, for the exam, you could use the, now that I think about it, go ahead and use the Excel. So learn how to use the Excel, and then also learn how to use your calculator. Okay? So that's that. We'll come back to that at a later date. Any questions on the COGO, coordinate geometry? Anybody? Bueller? Okay. Can you guys still hear me?
Yep.
Yes, we can.
Yep. Yeah.
Okay. Burger King. Not one of my favorites. Ooh, probably shouldn't have said that on a recording, but I like some of their food. Anyway, this one, a little bit trickier to do. Here's the aerial layout, the actual building itself. This is the drawing C3 that you were given. And the marked up C3 is right here. This one, not so good on the homework. What you're looking for are tie-off points that go directly to a corner of the building. So the first thing you want to do is kind of zoom in on that corner. And you really don't see anything over to this corner or this corner, but you do see some arrows, and they're not easy to find, but you do see some arrows on this corner and this corner. I kind of hatched it in blue. That's the actual Burger King itself. And so if you follow this arrow, we're going to pick this one in red and then this one in green. If you follow this arrow, you've got a dimension of 86.59 going back to what? What are they measuring to? They're not measuring to a control point. They haven't given you any control points. So what are they measuring?
Property line.
The property line, okay? Which eventually the property line is based on points that you can find in the field. 3 out of the 4. So you had to show me in your sketchbook, you had to show me the building, you had to show me this 86.59 up to this property line. I wanted to see that. I wanted to see the, this bearing and distance goes from this 5/8 inch pin that was set over to, whoops, nothing there. We'll talk about that in a minute. Okay. But you come up to this point, and then the distance that I wanted to see was 103.87. Well, if that's 103.87 to there, you could have subtracted it from this distance, which gets you back to that pin that you actually can physically find in the field. Okay. So that's about as much as I could find these 2 points for horizontal control to lay this building out. Okay. If you go over to any questions on that. We haven't talked about part C, which we will, because that'll be homework that's due. And we'll discuss when that would work for you to be due. Part C, think about bullet format in your field book. List equipment with each step. Okay. So really all I'm going to be looking for are how do we locate these 2 points. Once we locate these 2 points, we can do offset points, and we can locate any one of these other points along the building by either using this civil drawing C3 or the structural drawings, which you do not have. Okay. This point over here, it's got another arrow. Again, not easy to see, but it's got a dimension 67.36 that goes from the building over to this property line. And then this green line right here is the same as this, which shows they should have shown that as being a 90 degrees. You'd have to assume that that was 90 degrees to that property line here. and then to this property line here. So this is a 90 degree coming off of this property line. 16.36 gets you over to that corner. Where on that property line is this point? Well, it's not 44.20. That goes back to the start of a curve for the entrance into the BK. It's actually the 69.9, which goes from this intersection of at a right angle of that 67.36 foot dimension back to a capped pin found. So that's cap pin found. Okay. You've got a bearing and distance here that you can use. You've got a bearing and distance here, which gets you over to a 5/8 inch pin set. Okay. So really, if you zoom out of the 4 property corners, you've got 3. Okay. Now, what office work, let me write myself some notes here. We're going to assume, you want to write this down somewhere, assume no obstructions. Because if you go back to the aerial, and I got to bring it back over. Go back to the aerial. There might be a little obstruction right here, but there's really no obstructions, right? Now this is after the thing was built, so we're going to assume that there were no obstructions. There might have been a couple of trees, okay? So assuming no obstructions, what office work would you want to do before you, you go out to the site, you walk the site, and then you go back to the office? And using Civil 3D, what activities would you work on in the, I'm going to go to this one. What activities would you work, what could you do in the office before you went back out to the site to lay out these 2 corners? All you're given is this PDF. You're not given the CAD drawing. You're not given the original survey. But you have Civil 3D at your disposal. So what would you do?
Find your benchmark and set your pins.
Now your benchmark has nothing to do with your pins. Okay, that was part of the assignment that was due last night. So the benchmark was there, and then there's its elevation. Okay, and the benchmark has no coordinates, so there's really no tie-offs to that.
Hey, Mr. McKeegan.
Yeah.
Bianca's in the waiting room.
Who?
Bianca.
Oh, thank you. And also Mr. Hopkins. Great. Yeah, just chime right in if I don't pay attention to the waiting room. Okay, so let's go back. What can you do in the office? You learned how to do this for Spec House 1. You were given the survey. You were not given a CAD drawing of the survey, but you were given the paper on the survey, the PDF, if you will. And what did we teach you what to do with that survey?
Find other set pins.
No, well, if you could, how?
Like it says 5/8 inch, 5/8 inch pin set on like the far right corner right there.
Yeah, but that's not gonna, that'll be a label on Civil 3D. So what can you do?
Oh, the manhole?
Nope. Come on, guys.
Scale out and find distance.
Both of these corners, what are both of these corners tied off to?
The corner of the building.
No, these two corners of the building are tied off to what? They have a tie off,
Oh, the property line,
the property line. And how do you define a property line?
the setback.
Bearing? No,
By the bearings, the coordinate
Oh.
bearings. You could
The
draw.
bearings.
You could draw yourself a mini map back at the office and get a game plan inside of that of where you can set the building and start locating everything.
exactly. If you plot, you just set this point any place on the computer. You can give it any northing and easting you want. And then you draw in the bearing and the distance. That's going to give you this point. And you draw the bearing and the distance. That's going to give you this point, even though it doesn't exist out in the field. And then from there, you draw this bearing and distance to this point. You now have this polygon, okay? And then from there, how do you locate this building corner? Now that you've located this, you've located that little, that property line. Using CAD, you now have these four corners. Let me zoom out just a little bit. Right, you got these four property lines. You got them all plotted. Now, how do you find this corner and this corner on CAD? When in doubt, what?
Offset.
Offset. So if you offset this line 67.36 feet, okay, it's going to be a line right there. And then you offset from here, you go that 69.9, that gives you that point. And then there, 90 degrees will give you that point. So you now have that coordinate for that corner right there. How much do you offset this point? Or this line? I want these steps written in the homework. So I want the homework for part 3, the bullet format. How are you going to lay out this structure? I want you to describe exactly what we're talking about. And you can actually, I'm not going to make you do it, but you can get on Civil 3D. That was part of the email that I sent you, that software is available through Horizon. So check that out. But you're going to take this line that you plotted in Civil 3D, and you're going to offset it 86.59 feet. Okay. You're then going to offset 103.87 from this point. That'll give you this point right here. Draw a perpendicular line from here to here. You now have the 2 points. You actually now have their coordinates. The northing and easting for this, the northing and easting for this. I think next year, God willing, and the creek don't rise, we may just put this on Civil 3D while we're in the lab.
I have a question.
Yeah.
So when you're laying out the back left corner, so that 67.36, so the right angle is like right at the end of that, following back up the property line?
Well, here's 67.36. I'm not sure what your question is.
So the right angle is created right at the end of that, the 67, right?
Yeah, right here.
Okay, thanks.
So that's, and that was on the, oh, I thought it was. Oh, there it is. What the hell is this? Oh, this is just the, oh, there it is. Okay, sorry. So yeah, this is a right angle. It's got to be a right angle. There's no other way to do it.
After the 67.36, then it was 100 point what?
108, I think.
See this 69.90 right here
Yeah.
is measured from an imaginary line between this capped pin found and this one, which you've located on CAD. Right? In other words, you could just offset this 5 feet, draw in this little line. This little line is 90 degrees to this. Then offset this one, 69.9, and now you have the point right on this property line that's 69.9 feet away from here. Then you offset this entire property line 67.36, boom, and it comes over to here. There's a big line right here. And then you just draw a point from here, 90 degrees to this line, and set a new point, and that's your building corner. Okay? That's your building.
Mr. McKeegan, Damien's in the waiting room.
Yep, I just let him in. I saw it too. Thank you. Okay, so you're doing everything on CAD, but when you on the computer, you got a big blank screen. Set this point at say north 2000, east 4000. That sets the point. Okay, and then you can just start to do all of these bearings and distances just like you did. And we didn't do it very often. That's why I'm not going to make it an assignment. But we could go into units and get surveyor's units, and we can plot each of these lines, bearings and distances. And then you're just doing all these offsets to get to here. And you've established 2 points with their northing and easting. Okay. I just write myself some notes. So now you've got some CAD drawing, and you go out to the field, and let's say you have a laptop with this, with the Excel, okay? But the thing is, where are you going to set up over? You know, that's the $1 million question. Let me go back to this. Right? What physical point are you going to set up over? And this one, Mr. Van Duzen and a friend of ours, Kevin Yurden, who's a surveyor, helped us with this idea. You can set up anywhere as long as you can see, you could set up right here, put your instrument right here, shoot a distance to here, shoot a distance to there. If you had your laptop, on your laptop, you could do a circle radius from this point, the same distance as it is to your EDM. You strike that arc. You do the same thing over here. You strike that arc. That's the point you're set up over. You now have the northing and easting. And from there, you can do all the coordinate geometry. Okay. So see if you can figure out how you're going to set up the instrument using the CAD drawing and using coordinate geometry. Because another method could be, and don't tell anybody you're going to do this, because you usually don't like to set up over property points. But you can make the argument that you want to set up over this point and backsite what? Backsite
The other property line?
Right, backside another property pin. You now have 2 points in the field. You can calculate this angle, or you can go to your CAD drawing and find what that angle is, right? So you backsighted here, you zeroed it, you swing that angle, you now have the line of sight up to here, don't you? So now you're going to do what? I've set up here, I backsighted, I zeroed, I swing this angle. I now have a line of sight looking up to this pin. I can actually set the pin, even though I'm not going to because I'm not a professional surveyor. But what point would I want to set when I have a line of sight looking this way?
The 60 or the 69.69 point.
Right, 69.90. With the total station, you keep your line of sight till you're hitting 60, until you get a distance of 69.90. You set that point, right? You now set up over that point, back sight here, swing 90 degrees, boom, there's your corner. So think about how you could do it with setting up anywhere. And I may have confused you doing that. But it should make sense how you would set up, how would you be able to find this point and this point using the known points in the field. Okay? That's what I'm looking for in part 3. I want to know how you're going to set these two corners by physically going out there with your CAD drawing and your Excel, and how you're going to set up over, how you're going to physically locate these 2 points, and then from there find this point, set this point, and set this point. You really want to start thinking between yourselves, talk to each other, what the step-by-step function is. You are at a disadvantage. You've only had one lab. You've only had one lab where you've actually run the instruments. And when you come back in the fall, and hopefully we have these labs, then you're going to be doing exercises like this. Okay? Now, what day would you like that due?
So is this the drawing in the field book still?
Yeah, you're going to put in your field book, right?
Because it says it was due yesterday, last night.
Yep. It was. That was part 1 and 2.
Oh, okay. Thank you.
Now you're looking at part
3 was
3.
due also.
Nope.
Huh.
It's part 1 and 2.
Part 3 is the one that's going to be due whenever we pick it, right?
Right. So bullet format in your field book. List the equipment with each step. Describe parts of the structure and or property lines as required. In other words, how do you use the horizontal control info from part 1 to physically lay out those 2 building corners? Use the aerial. You can even mark up the aerial, but you got to put your step-by-step in the field book, and that's what you're going to submit. So this is Monday night. We only meet once a week for surveying. You've got other homework to do that we're going to go at a very nice, slow pace. You'll have at least one other homework assignment between now and next Monday. So what do you think? Wednesday night at midnight, is that doable?
Yeah.
Thursday night, you tell me.
Yeah, can
Actually,
we do
Thursday's
Thursday?
probably better.
Yeah.
You want Thursday?
Yep.
Okay, so that's going to be April 15th at 11:59 p.m.
Thursday is the 16th.
What did I say? Oh, yeah. Thank you. So Thursday is the 16th for part 3. I want it looking nice, folks. Okay, really start thinking about what you're doing. Setting up over a point, backsighting, zero, swing an angle. So if you're going to swing an angle, say you set up here, backsight here and zero it, what is that angle? I want you to tell me what that is. You should be able to figure that out. Okay? Based on bearings. So go back to chapter 14 and that'll help you a little bit. Based on bearings. Okay? So that's that. And if you get a good grasp of this, you guys should be looking for jobs in the surveying, construction surveying or just boundary surveying. Okay, where'd I put my last? Okay, I'm going to stop the. I'm going to pause. Okay, we are now going to go to the handout that I gave you. I both emailed it to you and I posted it to Vanco. Okay. And what this is the beginning of setting up a notebook to take topographic data. Okay, for a topographic survey. And we're going to go over this very slowly. We're going to take 2 weeks to do this tonight, the rest of tonight, and all of next week. And then we'll get back to coordinate geometry. So when you go out and you do a topo survey, the total station right here is taking horizontal distances, horizontal angles, and vertical distances, okay? And this is the, I think the first thing that's gonna be due, well, here's the old total station. You have a handout of that, which tells you each of those components, okay? Gives you each of those components. And we want you to identify those components, and let's have that due, what do you figure, Friday night? Saturday night?
Either one.
Saturday.
It'll be Saturday. And that is the 18th, right? At 11:59 p.m. Easy 20 points.
Now, just this page is what's due Saturday, or the entire?
Well, I'm going to put this all on Vanco, but there's going to be one other easy assignment between now and next Monday. So there's going to be a third assignment, which will probably be due Sunday night, but it's going to be very easy. Okay. So this is using the total station, and Mr. Martin and I might be going out and doing a little video, if they'll let us on campus, showing how to use this, okay? So this is how you're going to set up your notebook. It's going to look like this, but imagine, and this is Murphy, right?
O'Connor.
Yes,
That's
Or
O'Connor.
yeah, I don't know.
that's Murphy.
Murphy, right? And this is oh God, it's been so long since
Russell.
on campus. I forgot what the hell it is. I probably forgot where Smith is. That's Russell Hall. And so what we did is, it was just a great place to set up the total station to show taking a downhill shot to the prism and then taking an uphill shot to the prism. Now, according to this data right here, my instrument is set up at delta 1, and this delta means what? This triangle. What's that mean? What's another word for delta?
Like change or difference.
Change.
Nope. It's a control point,
Or shit, yeah.
okay? I got to give you guys a test. I got to figure out how to do that. I'll get with Mr. Van Duzen. Just on the basics. Okay. So delta 1 is the same as saying CP1, control point 1. Let's say I'm doing a topo survey of the area between Murphy and Russell. And I set up a control point right here. And I'm going to backsite delta 2, which is the same as saying backsiting CP2. CP2, the backsite is not shown, okay, because I don't have a drone shot on this. I've got more of an elevation photograph. If any of you have a drone, actually, I think the college has a drone. I want to get some drone pictures. They really show up well. So what you want to do here is let's see, maybe I'll go to the Word doc. So let me go to the Word doc. Ooh. We got Max Mick, and they didn't write their whole name, so I don't know. Is McNally already here? Well, you think we trust admitting this guy?
Yeah, sure.
Yeah, easy for you to say. Anybody know McNally's cell phone?
No.
Okay. This guy is an anarchist. We'll boot him the hell back out, okay? Hey, Mr. McNally, is that you? That's not good.
Tenants are not paying rent. How much worse can things?
Oh, we're gonna put in waiting room. Okay. Now, let's go back to here. So on here, again, make some notes for yourself. Delta means what?
Control point.
Control point. So if I'm backsiting delta 2 and delta 2 is not shown, maybe it's up in here somewhere. Hell, maybe it's up on the corner. I put one of the students up on the corner of the roof at Russell. Okay, that's my control point. I'm kidding. What should the horizontal angle be from delta 1 to delta 2?
What do you mean? The exact number? Or just positive and negative?
What do you think I mean there, folks? I'm setting up at delta 1. My backside is delta 2. What's my horizontal angle?
0.
Thank you. There was a big tear that was almost starting in the left eye. Well, that didn't go over well, but I thought it was funny. So that would be, that would be 0. Okay? So it's kind of a trick question. Just try to visualize what we're talking about as I do this. And again, I'm recording. Ooh, I better make sure that I'm recording. Yep, I'm still recording. Okay, so I'm backsiting delta 2, and I want to locate the benchmark. What do you think the benchmark is right here? It's hard to see.
Is it a manhole cover?
Yep, but I'm not going to shoot the cover because the cover can come off.
You shoot the rim?
I'm going to shoot the rim. I take a little cold chisel, which is like not a wood chisel, but a metal chisel, or what we call a cold chisel, and I'll make an X, or I'll put a dimple in the rim so that the point on the prism pole sits right on there. And Mr. I right here is holding that plumb, right? Because there's a little fisheye bubble level on the prism pole. And then this person is lining up the what?
The
Pairs.
total station.
the crosshairs of the total station to hit right dead in the middle of that prism. Remember that prism had a focal point in the mirror, okay? And what it does is it sends out a little photon torpedo from Star Trek. Actually, it's a light wave, infrared wave, I can't remember, it doesn't matter. Sends a photon torpedo and it reflects off this prism, burps back to the total station, and immediately gives me a horizontal distance of 19.99 feet. So the horizontal distance from here to here is 19.99 feet. And the vertical distance of negative 4.37. Why is it negative?
Because you're going down.
Because I'm looking downhill. So V right here is the distance from the center of the prism to an imaginary horizontal line through the center of the telescope. No. Right here, this is M. That is the pivot point of the telescope. It also is the HI line. Ooh, I just gave you an answer. We're in America, you can do shit like that, okay? Oh, shouldn't have said that. Now, does that make sense? So that dot right there, there's actually two dots on this total station, and it literally is the center axis of the telescope. The telescope can rotate up and down. So here, again, that's the HI. We'll talk about that in a minute here. Are you with me so far? Stop me at any point that you're confused. Now didn't we fire up the total station in one of the lectures?
Yeah.
Yeah, and we took some data for you. So the data here, the total station is at control point 1, backsighting control point 2. That's my zero angle. I shoot the benchmark, the horizontal distance to the benchmark from the control point. No. From here, horizontally is 19.99 feet. Vertical down, the V is negative 4.37. Where'd I get the elevation of 100?
That's
You
your
just
starting
decided that's
elevation.
what it was going to be.
I assumed it, right? That's not 100 feet above sea level. Now, I could have gotten an exact one based on a USGS hub, but we're just calling it elevation 100. Okay? Now, I also wanted to take a shot on the edge of the road. I'm going to take 100 shots to define. I'm going to shoot the corner of Murphy. I'm going to shoot this walkway. I'm going to shoot this retaining wall. Will I shoot that truck?
You could.
But I don't want to. It's moving. That was a joke. Okay? I can shoot the corner of Russell. This other annex, the other wing of Russell. The center line of the road. A couple of shots along the ground. These pine trees right here. So I only took 3 points that I'm shooting right now. And you're going to do this. You're going to take a topo of the area between the wall complex, which is right next to Smith, the maintenance building, and the soccer field, because we want to put a sidewalk along the back. All you college kids just walk in the center line of the road. I did it the one day too, and boy, they come peeling around there. Okay, so we're going to find control points. We're going to have back sights, and so on. So if I take a shot, I would rotate and the last thing, the benchmark had a horizontal angle of 125, 44, 40 off of the zero line. So everything's got to have a horizontal angle, horizontal distance, vertical distance. Why would I want to shoot the edge of road? Because I want to define the road. Okay. Now, what have I done differently with the prism here versus here?
You've extended it.
I've extended it, and that is called a high prism. Anytime you put HP next to the vertical distance that is measured by the total station, right, it's got a different prism height. Okay, so
Why did you do that if you don't have a machine that high?
well, I only did, typically you do that when there's an obstruction. The reason I did it here was to generate this, this handout. So good question.
Oh, just to show us?
Yeah, I didn't really need to extend that prism, but I wanted to do it for this handout. I should have had a student standing right there to be an obstruction. Okay. So that edge of road, the horizontal distance from here horizontally to this shot on the edge of road is 25.66 feet. Is that you? Mr. McNally, is that you?
Y'all missed me?
Mr. McNally, you here?
Sir.
This is so much.
He's not part of our class.
Yeah,
All righty then. We're putting them back in the waiting room. Now, so the vertical distance measured from the prism to an imaginary line through the center of that telescope, right, is 8.45 feet. It's 8.45 feet, okay? And then that had, we don't have an aerial photo, so we're not showing you the horizontal angle. Frankly, I made them up, but it's got to have a horizontal angle to locate that in what view. You need a horizontal distance, horizontal angle to locate a point in what view on a civil drawing. Plan or section?
Plan.
Plan. Good. Okay. So we're going to show you how to calculate these elevations by hand. Okay. Civil 3D does this all automatically, but we want to show you the geometry so that, see, I don't have, actually I just bought a laser level, but before that, I only had an old total station. And so I can use that as a level. But I'm not putting the telescope level, I'm shooting downhill or I'm shooting uphill to points that I need elevations for. Okay. So I'm looking downhill at the benchmark and I have an uphill data shot. So how would I calculate using the geometry and the handout that you have here? How would I calculate the HI, starting from a point of known elevation, which is the benchmark? Oh shit, what do I do here? 0. So the HI is equal to what? So if you haven't made a copy of this, no biggie, write this down.
The HI is equal to 100 plus you turn that vertical distance from the benchmark into positive, add that to it, and then add in the IH. And there's your HI.
Nope.
No?
You're close. You started very well because you started at the benchmark. But what data gets me from here up to this imaginary horizontal line? You're right about using V.
It's the prism height plus V.
Right.
Oh, my bad.
Well, that's okay. You were starting out plus. Somebody want to shut that dog up, please? Oh God. Plus V. But V is negative because in my data book, it's negative because I was shooting downhill, but it's the absolute value of V. So what I'm going to do is I'm going to put these two little lines, and that's the absolute value of V. Does that make sense? It makes sense when you look at the picture. So it's benchmark plus P plus B. So that equals 100 plus, what was P?
5.5.
5.50 feet. And what's the absolute value of V?
4.37.
7 feet. And so that's, so HI is 105.5 plus 105.5 plus 4.37 is 109.87. Okay? You with me? Any questions to this point? So this elevation, the HI, is 109.87. Okay? 109.87. Now, how do I get the elevation of this point at the edge of the road? I now know I have HI. How do I get from here to the elevation of that point? By using V and the prism height. How would I do that? In other words, you're kind of following the yellow brick road. Anybody see Wizard of Oz last week?
No.
I'm just trying to make conversation here. Okay. So I know the elevation of HI. I got to HI by following the yellow brick road from the benchmark plus the prism height plus V. No. I go all the way across here. Okay. What am I going to do now?
Plus V minus HP.
You got it. I go up to here. I'm like an American Ninja Warrior. I'm at HI. Whoop, go up V, come across, drop down HP. There's the elevation of my edge of road. So the elevation is equal to HI. Whoops. Why is that doing that? Oh, it's over here, guys. Let's see here. Equals HI plus V, and that makes sense because V is now a positive. HI plus V, that gets me up to the elevation of the prism mirror. I drop down and then I minus the high prism. Equals 109.87 feet plus 8.45 minus, what's the high prism?
No, it's plus 7.16 minus 8.45.
No,
8.45 is your high prism, correct?
no. 8.54, that's a good question. 8.45 is the vertical distance. HP is written up here as high prism as 9.5. That's okay. So I had 109.87 plus 8.45 minus 9.50, which is the high prism. So plus 8.45 minus 9.5 equals 108.82. Okay. Is that making a little bit of sense for you?
Yeah.
Mhm.
And then, how would you get the elevation of delta 2? Because you're looking uphill at delta 2, CP2, because that's a positive vertical distance. So it would be HI plus this V, but now the prism height is what? 5.50, because it does not say HP. Okay. So see if you can figure out that elevation. See if you can figure that out. So let's go to another situation. Now all of a sudden, I'm picking the benchmark, and the benchmark is an uphill shot. Okay? And this is there's two cases. You're either looking downhill at the benchmark, or you're looking uphill at the benchmark. It's one of the two, right? The benchmark is never going to be at the same imaginary horizontal plane. So do you understand what we're doing now? No longer is this the benchmark. Just to show, if you have an uphill benchmark, let's say I had a hammer drill, and I drilled a hole into that granite curb, and I put a PK nail there for a benchmark. Or I put a PK nail, say, in the asphalt pavement. What's the horizontal angle here for CP2?
0.
0. So if you go back to the go back to the data. Okay, go back to the data. Whoops. How do I mute that thing? My pacemaker's going off, so just a minute here. Ooh, looks like Steve McKeegan is trying to get into the lecture. That's interesting. Okay, so how do you get the HI now when you have an uphill benchmark? You always benchmark, right? I start at the benchmark. That's elevation 100. Now you're going to say, well, I thought that was 100. The numbers from the these two cases are not related, okay? So how do I get from here to here vertically? Just either going uphill or down.
Subtract your V from height of, or high prism.
No, because I'm starting here.
Add HP, then subtract V.
Right.
No,
Hopkins, you might have been right, but I want you to start from the point of known elevation. You have physically measured this high prism, so you're going to add the high prism. That gets you up to here. You're an American Ninja Warrior. You're here, whoop, you go up there 9.5 feet. You come across, come across. Instrument is giving you a vertical distance of 8.45 feet. But when you have an uphill benchmark, you're actually going to subtract V, even though it's positive. Whereas before, remember, if this were the benchmark and I wanted this elevation, I've already got the benchmark over here. I went
Yeah.
positive V minus the prism. So when you're establishing the sky, you're either looking uphill or downhill. So this is equals. The benchmark is 100. You're going to add the high prism of 9.50 feet, and you're going to subtract 8.45 feet, and that's going to give you a new HI. So it's 109.5 minus 8.45 equals 101.05 feet. It's just vertical, dealing with the prism height and the vertical distance, just to calculate these elevations. So now I know the HI. Now how can I figure out the manhole rim? So that's going to be,
HI minus V minus P.
it's going to be HI minus V, which is minus 4.37, minus the prism height, is going to give you the manhole rim elevation, because that's no longer my my benchmark. Okay. Does the photograph help? I mean, is
Yeah, yeah.
because this is going to be probably on your final. If this will not be on, say, a test that I give in the next week or two. Okay. But it will be on the last final. Depending on what Delhi does to bring you back for labs, I'm not sure if I'll give the final when you come back, or probably like to get it done here. Okay. So here's some exercises. We're going to go over this again next week. What I'd like you to do, I'm not going to grade it. I probably shouldn't even tell you that. I want you to understand all of how we got these numbers here. These are made up, these horizontal angles. This has to be 0 because it's the backside. I want you to understand how we got the elevations of these two and how we calculated the HIs. Okay. Same thing with this one. So you got case 1 and you got case 2. See if you can figure out how we got these elevation values. Study that over the week. Now, what is due, okay, what is due, and will be due Sunday, and we're going to review all the due dates so that you're in agreement. Probably missed about 11, let's see, there was about 10 that were missing from the Burger King layout, 5 or 6 from the coal yard, 5 from the survey. If you're not handing in the homework, you might want to look at your, and I'll try to get these updated, you might want to look at your midterm grade. If you've handed in no homework, you're not doing anything, and you got a really bad, you got a low F at midterm, you may want to consider dropping the course. And I may reach out to a couple of you, not many of you. So what we're going to do here is, in your field book, this is going to be due. I want you to enter all the data, okay, for this one in your field book. Only for this data. These are HI exercises. This one Both of these will be due after we talk a week from tonight. So they're not, the math is not due, but you've got to enter all this data into the field book, just like you see here. So all of this data is entered in the field book right here. I'm going to show you how to make a sketch. And this sketch is basically sketching this. Okay? And I'm going to do a really crude one. I'll show you in a minute. Okay? So the shot number and description, like shot 1, delta 2, shot 2, benchmark, shot 3, TOS means toe of slope, and shot 4 is, TOB, which is top of bank. These are just made up numbers, okay? So you can see that I've taken this data and I've shown you where I want it put in the field book. So you're going to duplicate this. Does that make sense?
Yep.
And then you're going to take a picture of it, and that's going to be due Sunday night, which is for 19. Sunday is the 19th at 11:59 p.m. Easy 20 points. You're going to take all this data, put it into here.
Can you repeat that? What day was it?
Repeat what?
Can you repeat what day it was due?
It's going to be Sunday.
All right.
Because I want to have it graded by the time we talk again a week from tonight. But it's just data entry. There's no calcs, plus a sketch. Now the sketch, I used to do a sketch in class before I generated this handout. And the sketch, let's see if I can pull this off here, is going to look like this. And this is going to be rough. Okay, so that is kind of the lay of the land, kind of like what you saw up here, right? Like that. Okay. Now, in this sketch, based on what you saw up here, where would the total station would be? Right about here, right? So your sketch is going to look like this. And a lot neater. No freehand. So there's your total station. And actually I should, and then here's your prism. And then here's your other prism. I always make these sketches when I have to do this as a test. Now, in the sketch, so that's one prism, that's the other prism. And then the HI, right there. And then you're going to label that HI. You're going to label this prism. You're going to label this P for prism. And then the, oh, where'd it go? And then the vertical, there's your vertical distance. Now you may want to get another straight line, right? So this is what your sketch is going to look like. Make it straight. And then you're going to, this is going to be labeled what? V, which is from the prism mirror to the HI. So you want to label this HI. This will be your instrument, your CP1, delta 1. Here's the V, which is from the top of the prism looking uphill to that imaginary line which is the HI. So that's what your sketch is going to look like. Okay? Fully labeled. So the sketch, and eventually your calcs are going to go here, but you don't have to do the calcs. It's just entering all the data by hand. Okay, I want a fully labeled sketch. Okay. Does that make sense?
Yeah.
That's what's due. And then try to figure out the numbers. If you can do the math, eventually, do it off to the side before you enter it in the field book. That way you don't have to erase. And we'll give you some hints on this next week. But try to understand all of the work here and try to understand all of the work here, okay? All you're doing for the elevation is you're either moving uphill or you're moving downhill. With this, either the V is data generated by the total station. How do we get P? We actually take a tape and physically measure it from here to here, from the point of the bottom of the pole to the center of that mirror, okay? And then probably do 2 weeks. Well, wouldn't be 2 weeks, but we'll go through what's due next week. So let's review. I'll put this right on Vanco as we, I'll put on Vanco all of these dates. The one date for the Burger King, we agreed on Thursday at 11:59 p.m., which is the 16th. Okay, everything's going to be in your field book. You're going to talk about the office work that has to be done using Civil 3D. You don't have to do it. You're just going to basically say that you're plotting the boundaries, which are bearings and distances. Okay, so Burger King, Thursday, 11:59 p.m. Saturday. What was Saturday? Oh, Saturday
18th.
was the 18th, and that was this filled out. I just want to see just the assignment that's due. Some of you are giving me too much. You're making work for me. Okay? Just fill these in. You've got the handout to help you with that. That's due Saturday. Throwing a lot of easy points at you. And then Sunday, you're going to show me pictures of your field book, fully labeled sketch, and all of this data is written in here. You do not have to calculate the elevations, but try to understand as much as you can with these first two examples that we went over. Okay? Everybody okay on that?
Yeah.
And I'll post that to Vanco. So now what I'm going to do is, oh shoot. You guys are still seeing my, what are you seeing? You're still seeing this Word doc?
Nope.
No.
Or you, okay. Damn it. There we go. Now you back to the Word doc?
Yeah.
Okay, so now we're talking about heavy civil. The liquid oxygen building estimating is now due Tuesday night at 11:59 p.m. And actually, I don't think there's anybody has shown up from heavy civil who does not have surveying. There's a couple of them and they're not showing up. So, okay. So again, here, what we're doing is with the openings, you know, we had a 10-foot wide door. This was actually 3'4", even though it says 3, I changed that, and 3'4". They're all the same height, 7'4" high. So it's as if we're just taking them and just butting them side to side. That gives us, I don't know, what, a 16-foot, 8-inch wide door, as if they were just one door instead of 3. And then you can just treat it, that's how you treat it as an opening. Okay. I thought Jared Smith was already with us. Aren't you already with us, Mr. Smith? Well, let's try. Mr. Smith, is that you?
You got to give it a second to connect to audio.
Mr. Smith, you there? God damn it. Ooh, I watch my language. Well, okay. So I gotta get rid of this phone. Okay, sorry about that. So we got doors end to end, and so we're walking through the number of bond beams. Number of bond beams. I got to go back to my laser. The number of bond beams that are in that opening. So at 7'4", this is 4 foot to here, 4 foot to here, which is 8 feet. Come back 8 inches high. So there's 7'4", starts here all the way down to here. So there's only one bond beam in that opening. This bond beam acts as the header for the, or the lintel for the doors. Okay. I think on Thursday, that's going to be the last day that we're going to talk about masonry, and then we're going to talk about soils. And so what I'm going to do in the next day or two is I'm going to shoot you some photographs along with some details from the Catskill Hall dormitory and from the fitness center addition, both using concrete block and brick. And I may give you some identifications. We'll go over those handouts on Thursday. It'll be some really easy homework to do. And then I am going to give you a masonry test, and I got to decide on when to do that. I'm going to get some help from one of my colleagues on writing that test. So we'll make a very fair masonry test for you. That'll be test number 2, and then test number 3 will be soils. Okay. So do you have any questions on any of this estimating? Okay. No questions?
Wait, so just to be clear, it's due tomorrow at midnight now?
Yep. Well, 11:59, because I'll tell you quick. Let me stop. We'll put this on the recording. So we went to Washington D.C. one year, and I had the bus coming in at midnight Thursday night, but they thought that meant midnight Friday. And so luckily the week before, I called up just to confirm when we were going to have the bus. And I'll be damned if I hadn't called, the bus never would have showed up, and we would have had 44 kids having no transportation to Washington. Along those lines, we did move the Washington trip to September, and that is going to be from Thursday, September 10th through Sunday, the 13th. And as a rule, actually, you'll be sophomores. So the juniors get first dibs. We can take 22 students. And if, so it goes sophomores, then juniors. So think about that. That's a great trip. It'll cost you $50. And that includes the transportation down, the hotel, and going to some really cool projects. And we've had a number of students get internships with the contractors down in DC. And one of the students turned that internship into a full-time job. Actually, 3 of them have done that. So think about that for the fall. That's about it. Any other questions, concerns? Like I said, we're seeing a little too many of you not, and it's probably not any of you that are here, but are just not handing in the homework. This, these are easy points. Don't be losing the easy points.
I
Hey,
got
Mr.
a question,
McKeegan.
Mr. McKeegan.
Yeah.
I just looked again on under Con 150, and for the spec assignment, I know I submitted it and I also emailed it to you, but again, it's saying that I had nothing for submission still under that. Not this most recent assignment, but the one previous to it. I don't know
Yeah.
what's going on with that.
Let
Because
me
I've
just-
submitted it 3 times, I believe, with you, and it's
Well, send me I'm going to stop recording.